Hi everyone, I am Sarthak Agarwal. I am a master's student here at the University of Illinois Chicago. I've taken a course in cloud computing. This course is being taught by Professor Mark Grechnik, and this is going to be the walkthrough of homework 3 for that course. I'll share my screen. This is the repository of my homework submission. The microservice in this project has been built using the Akka framework using Scala. I've also created a front-end web application through which it'll be easier to interact with the microservice endpoints. I've built this web application using React.js. Now in this uh, in this homework, we create a police versus thief game. In this game, police and thief are placed at two random distinct nodes in a graph. The police aims to capture the thief. The thief tries to find the node with the valuable data inside it. The two players take turns. The players make requests to the API endpoints. In response, they get the information regarding their own position, their opponent's position, the distance between them and their opponents, and the distance between them and the valuable nodes. Based on this information, the police and the thief can make decisions on which node to hop on to next. Uh, Another rule in this game is that the thief must always move on to some different node, while the police can stay in the same node for as long as it wants. A very interesting aspect of the game is that the thief does not have visibility over the actual graph. What the thief sees is a modified version of the graph. These modifications in the graph represent the traps which the police might set up. If the thief by any chance walks into one of these traps, the thief would lose the game. The thief, however, gets the confidence score for each of the node it can hop onto. This confidence score is based on SimRank algorithm. SimRank is calculated between the modified graph and the original graph. And for each node it can hop onto, there'll be a confidence score attached to it. This confidence scores represents the likelihood that the node is not a trap. So high confidence score would mean that the node is actually part of the original graph and it's not a trap set up by the police. Of course, if the thief enters one of these traps, it would lose the game. My program has primarily three parts. The first part is the API service. This is in this project. Next, I have the front-end web application. I have it in this directory. And third is the HTTP client. I have it in this directory. This client is used to automatically play the game for a number of iterations. This program also has different strategies for the police and the thief. It would run the program for a certain number of iterations for each combination of strategy of police and thief. We would look more into it later. Now I've created Docker images for my microservice and for my front-end web application. Here are the files I use to create my Docker images. I've pushed my Docker images into my Docker Hub repository. We would use these images in the repository to set up the application on an EC2 machine. We would use Docker Compose to pull the images, the microservice image and the front-end web application image. You would also need an Nginx HTTP server to serve our front-end application. The Docker Compose file will take care of that. And once it pulls the images, it will create containers and run those containers. You would also need a default.conf file. This is used by the Nginx server. We would have to change this to our EC2 IP. Let's go ahead and start an EC2 instance. To do that, I must navigate to the EC2 service. I'll launch an instance. I would create an instance with this name. If we'll use the Amazon Linux distribution, that's fine. We'll use the T2 micro, that should be big enough. I've already set up a SSH key. I'm going to use that. We'll have to allow HTTPS and HTTP traffic. This is how our web page is going to be served using our Nginx server. Everything else seems fine. Let's launch this instance. Now our microservice is going to run on port 8080. We must go into security tab and open this port for outside traffic. This will enable us to make API calls directly to our microservice. Let's go ahead and do that. I'm gonna edit inbound rules. I'm gonna add rule. We want port 8080, and we're gonna allow traffic from everywhere. This seems fine. Let's save the rule. The security changes usually take some time to take effect. While this gets set up, let's get back to our README and go over through other parts of the homework. Once the EC2 machine is up and running, we're gonna install Docker on it. Next, we'll install Docker Compose on it. Once these two are set up, we'll finally run the Docker Compose command to start our containers. Once everything is up and running, we should be able to navigate to our web page. The web page would look something like this. Now, while the machine is getting set up, let's go and see the endpoints of my microservice. Now, microservice has these 4 endpoints. The first is the get status endpoint. This returns the current state of the game. I have the reset endpoint. This resets the game. This would basically just put thief and police on some random distinct nodes, and then a new game would be started. We have the move endpoints. These are just used to move the police and thief. Now, each of these 4 endpoints give the response in a similar format. the outputs would be in JSON format, which would be serialized version, the JSON serialized version of instances of this class. Now, what this class represents, it first has a message which would give some general information about the state of the game. In the data part, it has a tuple. The first entry in the tuple corresponds to the police data. The next entry is of the thief data. In the first entry, which corresponds to the police, we have this label in form of string. This will just have the value police in it. The next value in the tuple would have the current node of the police. Next, we have the map corresponding to the police. The keys in this map would correspond to the different nodes the police can hop onto. Now, each of those possible moves would have a corresponding tuple. In this tuple, the first entry would give information about distance from that node to the current thief node. The next entry here would give information about the distance from that node to the valuable data node. We have a similar information for the thief as well. This is just the label. This will have thief in it, the string thief in it. In the next value, we'll have the current node for the thief. For the thief, we'll have this corresponding map. Again, the keys of this map would be the nodes which the thief can move on to, the possible moves. Each of those possible moves would have a tuple. The first entry in the tuple would be the confidence score. This is the likelihood that that specific node is not a police trap. The next value would show the distance from the current police node to that node. Now our graph is directed. So distance from police to thief may not be equal to thief to police. So the second value would give information of distance from police node, the current police node, to this possible node, the node which can on which the thief can possibly hop onto. The third value here is the distance from that node to the valuable node. And those are all the endpoints we have. Seems like our EC2 machine is up and running now. This is our public IP for the EC2 machine. I'm going to copy that, paste it here. This is how the SSH command would look like. This would have the path to the SSH key file. I've already set it up. The user of our EC2 machine would be EC2 user. And then we have the public IP of the EC2 machine. I'm going to copy this. I'm going to open a new terminal and then fire this command. Now we have successfully logged into our EC2 machine. Now we got to create the Docker compose and the default config file. Let's first create the Docker compose file. gonna go to my README and copy this. This would pull the microservice and the front end images and also the image for the Nginx server. Let's get out of here. I'm gonna create default.conf. Take this data in. Here we must change the IP, the public IP, to what our machine has. Seems fine. Let's get out of here. Now, the next step would be to install Docker. Let's install Docker. Once Docker is installed, we're going to start the Docker service. Once that is done, we'll download Docker Compose. After the Docker Compose, we're going to give it the permissions. Now this is a library which I found that the AWS Linux distribution does not have. So I'm going to go ahead and install this. Depending on your distribution, you might not need to install this. Now, once everything is set up, we are ready to do sudo docker up. Now this would automatically pull the required images and start them in containers. The Docker Compose has its own network as well. We have defined it here, the webnet. Our Nginx server, our front end and our backend would be all connected to webnet and use that to talk to each other. Now we can see that our web application is up. Before going to the web page, let's first try accessing our API endpoints using Postman. I'm going to copy my IP address. We are on port 8080, and then let's see status as you get. We can see that we are able to make API calls to our microservice. Now, by default, police takes the first, and that's why we have the police. It's police start message. The police is on current node 20. It can hop on to node 53 or node 29 or node 20. For node 53, it is 11 units away from the current thief node and 2 units away from the valuable data node. And this, we have similar information for thief as well. The thief is currently on node 60. It has these possible moves it can make. It can move to node 46, node 20, or node 62. For node 46, the confidence score is 1. The distance from the current police node is 7 units, and then distance to the valuable data node is 8 units. Now let's try making a move. So we can do move. We'll do police because it's police's turn. And we're going to do post. And let's move it to Let's move into node 53. So we're gonna do 53. I'm gonna send the request. Now our police has moved to 53. These are the new details for police and thief. Now, because the police moved, the data for thief would also change because the distance from current police node to the possible thief moves would also change. Now let's move thief. We can move it to 46, 20, or 62. Let's move it to 46. Or let's move it to 62. Now thief is moved to 62, and this is police's turn now, and so on. Once the end condition is reached, the API would tell us in the message that the game is over. We can try the fourth endpoint too, that is the reset. This would just reset the game. It would place the police and thief to random nodes and we'll get a new state. Now let's get back to our browser. Now let's see the web app. Now to see the web app, we just need to go to our browser and put the public IP address of our EC2 machine. Now this is our web app. It has all the API endpoints we just saw in a more user-friendly way. It also shows the different information about police and thief in this nice table format. These are the graphs which the police and thief see. Police sees the actual graph. This is the original graph, and the thief sees the modified version of the graph, which has modification corresponding to the traps which the police has set. Both these original and perturbed graph have been created using Professor Mark Gretchenick's NetGame sim program. Link to his repos in my README. Now let's see the get status. The web page also shows the actual JSON response. So you can see that this is police's turn. Police is on node 30. Possible moves are 70. Possible moves are move to node 7 or move to node 30. The police can stay on the same node. And then node 7 is 4 units away from the current thief node and 5 units away from the valuable data node. Let's try making a couple of calls using this UI. So police is on node 7. Police is on node 30 and it can go to either 7 or 30. So let's move the police node to node 7. I'm going to move police. Police move to node 7. Now thief is at node 46 and can go to 61. There is no other option really. So we're just going to make it move thief. And then we can do it for as long as we want until the game end condition is reached, at which point the microservice would say something like game over, police won, please reset. Right. Now let's take a look at the HTTP client. Now I've created this HTTP client which can automatically play the game for many number of iterations. This HTTP client has different strategies for the police and for the thief. We have the naive police strategy. So in this, the police just chooses the node which has the least distance to the thief node. Now, this is actually not a very good strategy because thieves would also constantly move in most cases. And then because thief is constantly moving, the probability that the police would uh, catch on to it is very low. Because of it's a moving target. Um, then we have the smart police strategy in this. The police actually goes to the valuable node and waits for the thief there. Next, we have the thief strategies. We have the thief knife strategy. In this, the thief simply chooses a node which has the least distance to the valuable node and ignores any confidence score. The smart thief strategy, on the other hand, takes into account the confidence score. It first only considers the possible nodes, the possible move nodes where the confidence score is above a certain threshold. If none of the nodes have a confidence score above the threshold, the thief simply chooses the node with the highest confidence score. This confidence score is, of course, based on sim rank. Now, the client, this HTTP client, would run, it would play the game for a number of iterations for each combination of the thief and police strategy. Once it's done running, it'll output this YAML file. This YAML file would contain information about the wins and losses of police and thief for different combination of strategies. This client program is in this directory. I've already have it set up in my local, so I'll just open that for this demo. Let's go through the configuration file. So the first parameter the program needs is the IP address of our EC2 machine. So I'm gonna copy this, paste it here. It's gonna run on. It's gonna call the API on port 8080. We'll just run it for 10 iterations. It will take too long. The sim rank threshold for thief, that is the threshold the thief checks before making the move, is set to 0.1. Once the client runs the program for 10 iterations for each combination of strategies, it will output the consolidated results in this directory. Now let's run the client. Something seems wrong. Let's just check that. Seems like I forgot to give the HTTP. Forgot to give the protocol. It should work now. Now it's going to play the game 10 times for each combination of the strategies. Once it's done, it'll output the consolidated results. The client has played the game for the required number of times. And this is our output YAML. These numbers are not representative because we ran it only for 10 iterations, these numbers don't actually represent how good the strategy was, but this is just for the demo. It provides the number of wins and losses, the percentage of wins and losses for police and thief for different combinations of strategies used. Yeah, so that's all I had for the walkthrough. Thank you so much. I hope you enjoyed it.